All right, hey folks who happen to be in chat. Today, we did not have to reboot once, did we?
Zero reboots.
Zero reboots. So the first time.
Yes. One Visual Studio error though.
Yes.
Just a small one.
Just a baby one. I opened the wrong version of Visual Studio and then was wondering why it was not understanding my CMake properly and was very, very confused. But I now am using the correct version of Visual Studio.
Yes. Oh, I just realized I haven't closed a bunch of stuff. Hold on, going to the big camera. Closing, work chats, all these other things.
Yeah.
I should not be having open. All right, we're good.
All right, should we have a look at today's puzzle?
Yes, I can read it if you like.
Sounds good.
Because we took a brief peek, and this is a fun one. It is day 4, giant squid. You're already almost 1.5 kilometers, almost a mile below the surface of the ocean. Already so deep that you can't see any sunlight. What you can see, however, is a giant squid that has attached itself to the outside of your submarine. Maybe he wants to play bingo. So there's a little link here to Wikipedia. For folks who don't know bingo, we can explain how bingo works. Bingo is played on a set of boards, each consisting of a 5x5 grid of numbers. Numbers are chosen at random, and the chosen number is marked on all boards on which it appears. Numbers may not appear on all boards. If all numbers in any row or any column of a board are marked, that board wins, and there's no diagonals. So the submarine has a bingo subsystem to help passengers. Currently, you and the giant squid pass the time. That's not true. We have me, there's Sai, I think there's Marshmallow, and check it out, there's Nori. What?
No, Marshmallow's not here anymore. He wandered off.
He was screaming pre-stream.
He was screaming earlier. Yeah.
Pretty great. Okay, so that's at least 3 people in the squid. It automatically generates a random order in which to draw numbers and a random set of boards, your puzzle input. For example, and here's an example input, we have a long string of numbers, and then we have 3 example boards. So yeah, after first 5 numbers are drawn, 7, 4, 9, 5, and 11. So that's these first 5. There are no winners, but the boards are marked as follows, shown here adjacent to each other to save space. So here the numbers are highlighted on the boards. You can, it's kind of, I'm not sure how well it shows in stream, but 11 and 4 are highlighted here, 5 and 4 here, 4 and 5 there, right? There's no column completely selected, or is that no row completely selected, no column completely highlighted. After the next 6 numbers are drawn, 17, 23, 2, 0, 14, 21, there are still no winners. So you can see more numbers highlighted. And finally 24 is drawn. And then here, this board has 1 row completely highlighted. At this point, the third board wins because it has at least 1 complete row or column of marked numbers. In this case, the entire top row is marked, like there. The score of the winning board can now be calculated. Start by finding the sum of all unmarked numbers on that board. In this case, the sum is 188. Then multiply that sum by the number that was just called when the board won, 24, to get the final score. Oh, interesting. I thought we had to multiply the winning numbers, but we need to multiply all other numbers by the last number drawn. All right. To guarantee victory against the giant squid, figure out which board will win first. What will your final score be? Yay. All right.
All right, let's get started. Oh, wait, Marshmallow is here. He's just inside my drying rack.
Yeah. I guess something that we did today that we didn't do in the last couple of days is before stream, we sort of looked at this briefly and we were like, oh, how do we solve this? So we've already individually kind of gone over okay, will we get stuck? How do we know how to approach this?
No.
Yep.
So let's get started.
Yes. All right. Muting. See you in a bit. All right. Hey, everyone. Welcome to the Streamy Times Today we are streaming Rust, and I gotta turn off my RSI thing because we're not intensely coding. Yes. Oh, I need to make sure that my terminal is visible once more. Oh, okay. That looks good. Yay. All right. We have 2 cats behind us today. There's a naughty cat on the couchy. There's another cat doing something they shouldn't be. Hey, what are you doing?
A few moments later.
Welcome to cat herding, living with cats, co-living with cats. No, I just had to like run out and like put my cat in a little litter box. Because that did not go well. Okay. Luckily, crisis averted. I was like, hey, we have 7 people in chat. Pop in, say hi. Welcome, everyone. Okay. Okay. I hear the cat in the litter box being done. I'm grateful that we didn't just have an accident on stream.
Foreshadowing is a narrative device in which suggestions or warnings about events to come are dropped or planted.
Yeah, let's set up our files. day4.rs. What do we have here? We have our input, so 4.txt. Then here we're gonna do our thing. So we just covered everything we need to do for this little puzzle. So there we have 4, 4, 4. Then for convenience, we're just gonna quickly copy over the structure. I don't want to type it out again. We've been doing that a bunch. So 4, 4. We're gonna delete the input right there. To do. We're gonna delete this. I'm gonna copy this. Parse to do. We're gonna have our little puzzle example input from here. Like this is a full input. It's like pretty long. Yep. Right there. No, I think we can keep that, can't we? I'm sure we can. And then what else? I think that's about it. Do we have our main? We have our main. Do we have our puzzle input? We might as well. Just straighten out. Here we go. Complete puzzle input. Complete. Hey. And that is the base of it. There's a cat like still digging something in and it feels so sus. We're gonna have to check in again. Sorry, my cats are a bit unpredictable. Be right back.
A few moments later.
All right, we're back. So what just happened was my cat took a shit on my shoes. Good times. All right, but that's all cleaned up. I thoroughly washed my hands, and yeah. Hey Phil, welcome. Yeah, so I'm glad I tended to that because I was hearing like the suspicious I'm burying something into the wooden floor, which is never a good sound. So I'm okay. We averted 2 crises. First off, we made sure that didn't happen in the cute little basket right there, because she was about to go. And mistakes still happened, and we cleaned it up. So all good, all good. Hopefully the cat is now gonna clean herself. It's gonna be good, and I don't need to worry about it. And we can finish the first one here. All right. So what we need to do is we are going to do a, we want to split by double new line, essentially. Split. And we can give stir split any kind of pattern, which can be a string, right? So here we say double new line. And that will give us like our input and then like all of our boards. So I think that is step one. Let items equals s dot split. And we can't just give it a character. We need to like give it double new line. Input, or what do we call that? Answers, numbers, drawn? What do we call this? Let's just call it drawn equals items dot next dot unwrap. So we know that is always the first. And then we say items s dot split. Do we need to do intuiter? No, that implements iterator. Items dot collect. Boards equals items dot collect. Oh. And that is we collect into a vec. Drawn boards like that. All right, let's run the first test. It's gonna like panic, but that's okay. Right, then we say drawn, we have a sequence of numbers, and then we have boards, and then we have that. All right, so we need to parse. We need to like continue this, right? We want to like have a vec of numbers there and a vec of boards. So we want to do something. Let's start with the vec of numbers because that one's easy. So we want to have like a vec of U8s, dot split, dot next, dot unwrap. Hey, Mirstrom. So we're doing this today in Rust, the Rust programming language. And Sai, who is muted, but you can see in stream, is doing all the puzzles in C++. And you know, at the start we talk a bit about what's a problem, and then first checkpoint, we talk again for a second part, and then finally we hopefully are able to compare results, and we get to look at the Rust answer and the C++ answer. Yesterday we didn't get around to that because it took me 2.5 hours to like finish it, which was ridiculous. And so I was like done way sooner to like run. But hopefully today it will be a bit easier. I have a good feeling about this one. I bet like Sai like 5 seconds from now will be like, I'm done. It's like, yeah, okay. Dot collect, split. Dot map, c dot parse, and then here I believe we can say vec u8. Does this work? From iterator of elements. Oh yeah. I think we can just do that unwrap. Does that work? No, unfortunately. Dot unwrap. Does that work? That works. Maelstrom's asking, is it a web or app or a web page? No. We're doing Advent of Code. So this is a 25 puzzles starting December 1st until December 25th. There's 24 puzzles. And you do like one puzzle a day. It's kind of like just coding puzzles. They do these on interviews, things like these pretty often. But I think they're fun as well. If you like ever like want to interview at like a big corp, getting good at these kinds of things can help for some of the stages of the interview. Yep. Okay, so we're going to find another thing, a struct board, and the struct board will have Maelstrom's asking, can you give me the URI of the riddles? Look for advent of code, spelled advent of code. Hopefully you can see it here on stream. What if we up the font size? No, that's worse. All right. Hopefully it's readable. Advent like adventure, but without the year. And then of code. And yeah, they've been around for a couple of years. So, all right, we have our like drawn numbers. Oh, okay. Dan, you're asking me if I want to become famous. I don't. We banned that. Goodbye. Okay, let's see. Drawn next. All right, so we're defining our struct board where we have our columns, which is a vec of U8. And then we have our rows, which is the same deal. And then we say U8 pool. U8 pool. There we go. Yeah, I think that works. Board. All right. And then we say impl from stir for board. Oh, no, we need to import it. There we go. Stud. Is it? No. Stud stir parse bool error? No. UTF-8 error? No, we're just gonna do IO. Error, right? We're never going to error because this is just an example. Derive debug. So we can like look at the internals. That's okay. Okay, so we're gonna do a little parsing logic here. Right now it's marked to do. So what we'll do here is items dot map item. Actually, we should call it. Should we call this boards? No. So okay. So there's a board. Board. Actually, I want a vec of board. Let me say board dot parse dot collect. Oh, dot unwrap. There we go. Does that work? That works. Now we like need to implement the parsing internal. So taking a look again at like our input, right? A board is like multiple rows. So it's like split by row, and that becomes like our columns. Sorry, that becomes our rows. And then we like need to traverse every single row that we have. And that becomes like our column essentially. So from stir, we say s dot lines dot map. So then we have a line, and then we say line dot cars dot map. And then we have a car, and then we say c dot parse. No, c as U8. Is that? No, we had a issue with that yesterday. So we can't just like do a straight to U8 conversion. Sorry, not this one. I meant day 3 RS. So we need to like do a parsey thing where we actually proper parse it. Oh, here we did. Car equals 1. We want to convert it to like its string representation. I forget how to like go from a character to like a stir. Let's take a look. Is there like a toString? toString. We do have a toString. All right, we're just gonna do like a bunch of owned strings. No, we want numbers. Sorry. S U8. Try from. Give me try from. ST. Try from. Car. There's no try from car. That is annoying. Because C as U8 gives you like the ASCII like index or the Unicode index, which is not what we want. So we do want like per car, or well, let's do it a bit differently because cars is actually wrong. So line dot split by new line, and that will give us that. And then we say dot map, which is a string, not a car. And then we say s dot parse dot unwrap dot collect. Please work. Dot map, and I think we need to do another like collect here. Let rows equals, and that becomes a vec of U8. Yes. Please work. Oh, one too many. No closing delimiter. Did I mess up? I messed up. Does that work? Please work. Please work. Okay, there we go. Yeah. Sorry. It was like super narrow. Yeah. So what do we have? Yeah, this works. But we're not completely done yet because we want this to be a vec of U8 comma bool. But we can do it later where we like do like one more pass if we really want to. Or maybe not. I guess we can just do this and then comma false there. And then we say there, U8 bool. I mean, you're right. We could just like make it an enum. But like a tuple will like do a trick for us, like inline. If we have some time at the end, let's change it to enum. I like that suggestion because like this is terrible, right? We don't like this, but it works. And then we can do something like rows dot as ref. Let's do this one like in a non-methody way. Row in rows dot as ref, or better, rows dot iter. Is that right? No, that's not right. All right. So now we like need to create a columns, right? Let columns equals vec, and this is also a vec of U8 comma bool, right? And now what we want to do is we want to go over, so the way our board works is we now have like these rows, right? 22, 8, 12, 9, 6, 10, etc. Hey, welcome, Shirshak. Today puzzle was kind of irritating. Yeah, I can imagine. I don't mind it though. Oh, I think like our thing is wrong, by the way, because we are splitting by exactly 2 characters, but the characters are like variable with. So we need to do s.trim.parse. There we go. That should fix that. Cool. Because like otherwise we have like white space around the characters, and we like need to get rid of that. I hear a cat crying in the other room again. Oh no. Hold on, I need to go check in on the cats one more time. Be right back. This cat was dragging a toy. It is very cute. Yes, you're very cute. Hi. Yeah, exactly. Shurshick's asking, why am I doing like rows and columns in board? And the answer is because we need to detect either rows or columns. It seemed like easier to like do it slightly more object oriented, where we have a notion of a single board that we can like query, like, you know, add some methods on, like check for a bingo, right? I feel like I'm on a good track, so I don't like need hints like right now, but usually otherwise like yes, but I don't think I'm stuck. I'm doing quite good. I feel personally. Maybe I'm wrong, but we'll find out. No backseat coding quite yet. If I get like ultra stuck, I'll like ask for help, like 100%. Right. So we are just initializing like our rows and columns like here because we like need to verify those, and then we can like add some methods to like check the state of the board, essentially, to like add a number, do it like an object oriented manner. I like that. All right. Bum. So we will have, let's complete it first. Yeah, exactly. There's like no single right solution. Some people are like solving this in like Excel or like Game Boy Advance assembly. So truly there's no right way to do this. There's only like working ways and not working ways. It's like fun. Yeah, I like at the end I definitely want to take a look at like how other people have like gone about this. All right. So let's keep going. Crisis with cats, slightly averted, hopefully. You never know. So we don't quite want to like iterate over rows, do we? I guess we might. Yeah, actually for num and row. And we should be able to like just straight insert like every number of this row. So that would become columns. I think we like need to do an enumerate. Enumerate. Oh. J. So for column J, item I equals num. Is that right? Row.iter, the enumerate equals num. Expected tuple. Oh, so false? Is that right? Oh, this is a reference to a U8. Does that do the trick? Hold on. What is going on? Oh, num is a tuple. Num, comma, underscore. Like that? Are we happy now? Can I remove this deref? Unhappy. Okay, back to happy. Okay, sweet. All right, so we have our like rows and columns, and then we can do self rows columns. Right? Is that true? Okay, that's true now. All right, sweet. All right, so we have our drawn numbers, then we have our boards. Let's add a function or a method onto our board. What can we do? Add impl for board. Yes. Function, what do we say here? Mark number. And then num is U8 right there. And then what we will do is we'll first like walk the rows and then we will walk the boards. For row and rows. Rows dot iter mute. Oh, wait, hold on. And self dot rows. Iter mute. There we go. And then we say for num and nums. We will, or what is it? Num bool in nums? Is that right? No. Oh, in row. Is that true? Yeah, that is true. Okay. Dot iter mute. Do we need to do that? I don't think we do. Oh, otherwise it just straight clones it or copies it. Sorry. Okay, we have a lounged cat. There's a cat like, taking a little snooze right under a couchy. And then here we say if target equals num bool equals true. Expected U8, found and mute U8. All right. Like that? Sure. And then bool is true. And we're going to like repeat this once more. Actually, I think we can like straight move this to a thing. Extract into function, fun name. No, okay. Wait, hold on. Doesn't matter. Copy and pasting. Let's go. Self columns intermute. Sweet. So that is mark number. What's the error here? It says unused. Never used. Okay. Yeah. So what we'll do is for num in drawn, for board in boards dot iter mute, board dot mark number num. There we go. Right. So then we have marked our number. And maybe what we can do here is row, break row, column, break column, just so we have like an early exit. Like once we like find which one to break, we stop there. What we can do possibly even is like, if we like know that, now we're just gonna like create a separate like validate number sequence. Why? Because we don't particularly care about efficiency today. We care about solving it. Validate, which takes and self. Ooh. And here we do is for, hey UberX, thanks for the well wishes. I appreciate it. For row in self dot rows And then here we can do something to the effect of row dot iter dot fold false true, and then here we can do val let is done. Oh wait, can we like do instead of like a fold, can we like do a every or something? Iterator every all. Yes. Okay, we just do all. Row dot iter dot all val. Or what is it? Comma val, and that will return a bool. Let is done. Dot all. Hold on, what's going on here? We're missing something. For row and rows. To do? Better? No. Mismatched. Closing delimiter or something. Can't move out of self dot rows dot iter. Okay, so that works. Okay, so something's busted there. What is it? Oh, we're missing like a closing there. That's it. Mismatch type. Expected bool, found bool. Oh, it's easy. All right, so we have like a is done here. And if we found the row, validate. So we need to get the, we need to like know which number was done. If return true, and then we can copy and paste this. Self dot columns call return true false. Right. Board mark number if board dot validate there, and then we can do something to the effect of what's the puzzle thing that we need to do? It says the score of the winning board can now be calculated. Start by finding the sum of all unmarked numbers on that board. In this case, the sum is 188. Then multiply that by a number that was just called on the board, 24, to get the final score, 4512. Right. So, okay, one last method. Function. Sum unmarked and self. I think we can just like complete that. Usize. And once more, we're going to do for or easier. Self dot rows dot into iter dot filter map, or we could just do a dot filter. Where we say num comma predicate. Do we rename this to pred? We can rename this to marked. I like that. We simply do a mark there. Oh, was that wrong? Yeah, that's wrong. We need to close it there. Remove that there. Okay, rust bool dot then. If the bool is true, return the value. Otherwise, return nothing. All right. So maybe a filter map is easier. And then we say mark dot then num. Is that better? I feel like that's better. Dot sum let num equals as usize. Okay, what's going on here? Filter map. Okay, what do we have? What is the error? Expected struct vec bool u8 comma bool. Oh, we're not yet like iterating over each like row. We like need to iterate over dot map. We have like row here. And then here we say row dot filter map. Dot flatten. Dot sum. Filter map does not exist for vec. Okay, we need to like do into iter. There we go. Type annotations needed. Resize. Does that work? I think that works. Boom. All right, cool, good. And then we can repeat this for all the columns as well. Self dot calls call like that. Columns. Here we go. Call count. What is this? And this is row count. Row count plus call count. Okay. Sum unmarked. All right. And then we can do here if board.validate is board.sum unmarked. We simply say return board.sum unmarked, I believe. Cannot move out of board. All right. That makes sense because we're taking by own, but we're iterating like references. We should know that that is the end, but yeah, we can't express that quite yet. So that's okay. Self.rows. Self.rows.iter. .iter. And we just do that, I think. Yes, there we go. Lemma drawn. All right. So you never mutate that for enum in drawn. Unused variable s. Okay. Let's take a look. What do we have? Sum unmarked. Parse one, and that's our to do. And that's our panic, right? Because we always like return usize. All right, let's run our test. What do we expect? We expect the number 4512. So let's run a test. Boom, failure. Okay, what happened? Parse int error. Kind empty. AOC s.trim. Okay. Let's see what we're like trying to parse there. Whew. All right. So we are trying to parse the number 11 or something. Okay, line.split by that. And then we have, let's just add a filter, I think. So 22, 13, 17, 11. 22, 13, 17, 11. And that became a 0. Oh, yeah, there we go. All right, so we want to like split by white space. Does split accept it right? Regular expression. It doesn't. But we might be able to split by white space regardless. Stir. Let's take a look. Is there a method? Split. Split. Split, 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 split. Split white space. Hey, sick. Okay, there we go. We should always be using that. I should stop using the other one. White space. There we go. We can get rid of this trim. Attempted to take value of method filter. Oh, yeah, that makes sense. All right, let's run this again. Run test. Okay, way further. What's the issue now? The length is 0, but the index is 0. Oh, whoops. We're doing something with our indexing. Columns, J. Oh. Heh. We're not initializing properly, like with the length. We need to 0 initialize and then modify the board. So let's do that. I still have like a little bit of coffee. It's great. We don't need to trim the line, luckily, because we're using dot lines, which will remove all like trailing new lines. And then because we split by white space, it's like arbitrary white space. So we don't like need to like trim any redundant white space. That's already like part of the split white space method. So we're good. Right. That's why we're like making it out of that parsing stage, even though the white space is like variable. Split white space just handles it. Rust standard lib. I like it. Okay, cool. Some lines in the input start with space. I ran into that. Yeah, exactly. Split white space. I think just handles that. But we'll see. Maybe you're right. If we're into that, this will be really good to keep in mind. I don't think we should. We'll see, I guess. Oh, yeah. Are we like running straight into issues? No, we're not. So the 8 is correctly parsed right there, right? And this one starts with a white space right there. So we're good. We are handling that case already. Luckily. Hell yeah. Go standard lib. All right. So our issue is that we want to 0 initialize this. So I want to say 0, false, right? And then all we want to do here is .0 equals num, because we just need to set that. But then we like need to give these two lengths. How do we know what the length is? Okay, so the first vec, J, is the columns J. Rows.len. Oh yeah, it does it. Rows.len. It's always like a hexagonal grid. Yeah, we could like hard code to 5, but I think that will like do a trick as well. All right, let's run this again. Failed. 274, right? 451. Okay, so we make it all the way through, but then our output is wrong. Oh, that is because we're not multiplying it by the last input. Times num? Is that better? Can't multiply, you says, by... Okay, fine. Is that better? Okay, let's run this again. Run test. Oh, we're getting closer, aren't we? Left, 6, 5, 7, 6, 4, 5, 1, 2. Yeah, that is way closer. Let's actually start taking a look. So our current debug is no longer needed because we are parsing correctly. What do we need here? We have some intermediate like inputs, right? It will say something 188 times 24. So some unmarked. DBG. Oh, why doesn't it? Okay. DBG. Oh, like that. All right, let's run this again. One more time. Run test.
Hey, Josh.
Hey.
Yeah, I think I'm going to call it a day for this one. We got like the test puzzle working, but there's some problem with the code for the other one. I can't be bothered debugging it. The code's a mess. So I'm just going to call it a day.
Did you make it to the second one?
No.
No. All right. We are like so close on getting the first one done. Super close. We're so the test output is supposed to be like 4, 5, 1, 2. We're getting 6, 5, 7, 6, and there's a small bug somewhere. I don't know what it is yet, but we're super close.
Yep.
Oh, do you want to hear something fun?
Yeah.
I had to like run out of the stream like midway through twice. One time because Cheshu was like digging into the little basket, and I was like, uh-oh, that means someone's about to go. So I was like, oh yeah, you know what? I'll just grab Cheshu, I'll like carry her like to the restroom, you know, in her little litter box I put her in. So I'm like, I get back on the stream. And then I hear like scratchy sounds on the floor, and I'm like, oh no. And I go over and she's like taking a shit on my shoes.
Oh no.
So I had to like clean it up like midway through stream. So yeah, good times.
Yeah. All right. Well, get a head off. See you tomorrow.
Yes, I'll finish this up and I'll see you tomorrow. Catch you later. All right. So Sai's calling it a day, which I think is entirely fair. But we're so close that, you know, we'll get it. Yeah, exactly, Rusk. Oh my God, indeed. Cat dad, right? All right. So row count, call count. Oh, we're getting the same value twice. That seems sus. Is it because we are... Why is it? Oh, row into iter, row into iter. Self.columns, self.rows. Are we like setting it wrong? Self.rows. Okay, let's rename this to call. Self.rows the iter mute. Self.columns the iter mute. Self.rows the iter. Self.columns the iter. Oh, spoiler. Part 2 is super simple extension. Sick. Yeah. So the fact that we're like getting the same number on like both call and row is sus. That's so sus. Rows the iter. Debug. Row count, call count. That makes no sense. Oh, wait, hold on. 137. No, it needs to be 188. Oh, we don't like need to like... We just like need to go through them once. Hold on. That makes no sense. Because they're like not different. They're like unique. Unique. Okay. So that just needs to be count. Right. And if we run this again, it'll still be wrong, but we might get closer. Yeah, we're like undercutting it slightly, which is because we are, where's our thing? Let's take a look. Run tests. What is advent of code? Cody Senpai asks. Yeah, thanks. Thanks for explaining, chat. Okay, stack backtrace. 137, 188 times 24. Num is U size. So 24 is correct. Sum unmarked is wrong. So we're on the right number. It's just our sum is wrong. The entire top row is marked, right? So 10, 16, 15, 19, 18, 8, 26, etc. Sum of all unmarked numbers. Are we maybe like doing the sum of the marked numbers? Is that what's going on? Oh yeah, that's probably what's going on. Sum unmarked. Mark dot not. Dot then. Import sit-ups not. All right, let's try this again. Run first test. Hey, we got it. All right, sweet. Oh. Yay. Run, cargo, run, bin, AOC, 2021. Oh, we can remove this one. Hell yes. I did that this morning. Sick. All right. Let's run this one more time. Hold on. I want to run this one more time. Just so I make sure I copy the right number because I did that the wrong thing. Please don't not work for the real input. Yeah, exactly. Like yesterday I had like working for the real input, but copied like the answer of like the day before because I had like print lines in there. So that was my bad. Submit. Hey, 1 gold star. Hell yeah. Okay, part 2. Sweet. All right, I'm gonna have a sip of water and I'll like read this. All right, part 2. On the other hand, it might be wise to try a different strategy. Let the giant squid win. You aren't sure how many bingo boards a giant squid could play at once. So rather than waste time counting its arms, the safe thing to do is to figure out which board will win last and choose that one. That way, no matter which board it picks, it will win for sure. Huh? Wait, hold on. I'll need to reread that. Let's continue though. In the above example, the second board is the last to win, which happens after 13 is eventually called and its middle column is completely marked. If you were to keep playing until this point, the second board would have had a sum of unmarked numbers equal to 148 for a final score of 148 times 13, 1924. Figure out which board will win last. Once it wins, what would its final score be? All right, so we like need to sum marked instead of like unmarked. Right? Because that is the final score. Or you can do like a sum all and like subtract the number. Is that it? What would its final score be? Oh, no, it's like, it says sum of unmarked numbers still. Wait, hold on. All right, let's reread this. Would have a sum of unmarked numbers equal to 148 for a final score of 148 times 13, 194. Wait, what? Which board? Second board would be last to win. 13 would be there. Oh, just keep playing until all the boards win, as opposed to stopping after first one wins. My brain's a noodle. My brain is soup. I don't know. My brain is lasagna. No, it's way too tasty. I don't know. It's like I'm not particularly awake yet. I see what everyone's saying. Like, this one's easier. You're right. I just have trouble like understanding what I need to do. Hold on. I'll reread this. We got this. We can do comprehensive reading. I know I can do coding, but like, can I read? Who knows? Now we got this though. All right. The safe thing is to figure out which board will win last and choose that one. All right. So we try and find like the last board. So we do like a advent of reading comprehension. Yes, exactly. So I think like instead of like returning where we did is we start eliminating boards once they're done. That is step one for sure. And then in the above example, the second board is the last to win, which happens after 13 is eventually called and its middle column is completely marked. Oh, yeah. So 13 will be marked and then we like find like the unused numbers because there will still be like unused numbers. It's not like all the numbers are filled out at that point. If you were to keep playing until this point, the second board would have had a sum of unmarked numbers equal to 148 until the thing. Okay, yeah, that is a simple extension. Hey, let's go. Yes, let's turn this into a function, so we don't need to repeat that. Why do we have two here? Hold on. Items and drawn. Extract into function. Parse. Drawn. There we go. Okay, and then we copy this. A fun name is a fun name, isn't it? Blub. All right, where's our parse to? We had a parse to somewhere. Let's save this. Let's see where the issue is. All right, there we go. Bye. Fun name is a fun. Oh no, stop. All right, what do we got? All right, so we have our boards once more. Chat. All right. So the main thing that we do is we like stop there, right? So if board.validate, we're gonna add like a small thing to board, which is like is done, which is bool, and then we're gonna get an error right there. Yep. Is done. Oh, we just add that there. Is done false. Boop. Field never read. All right, that makes sense. That's okay. Yeah. So in the second one, what we say is like if board.validate, we say board dot is done equals true. Or do we say like mark done? We could just add a method called mark done. No, hold on. We have a field. I implemented this in Rust Analyzer. Let's make this happen. All right. Generate a setter method. Boom. Now we have a set is done. We're going to use that. Second board. We're going to do board dot set is done. And then we say true to that. No assignment. Only setting. When we rename this to mark done. Sweet. Check it out. It's got like set the boards is done. That's a terrible name. Mark the board as done. And that is fine. Mark done. True. Okay. Let board count equal boards.len. Let my done count equals 0. Done count plus equals 1, like there. And then if done count equals, is that boards.len? It's boards.len minus 1, right? board count. Then we do board sum unmarked. Do we still multiply by the sum of unmarked numbers times 13? And 13 comes from a thing, right? Probably just len. Is it? Yeah, you're probably right. Fine. Okay, let's just take a look if this like works. So 1924. No thought, only unit test. 1924. No. See, our score is like too high. Wait, but why? Why is our score too high? Like what are our components? What do we got? Let's take a quick peek here. Can I .dbg? Num. All right. Type U8 cannot be dereferenced. Fine, let's borrow that. Fine. Run second test, please. Board sum unmarked 137. Num 16. Why? Okay, so that is like turbo wrong. Our number definitely should not be 16. Right, where's num coming from? Board and board. Okay, so that's a number drawn. And then we have 16 somewhere. Oh, board.validate. So we say like if board validate, mark done true, if done count equals board count. What's the done count? What is the board count? I think you committed the same mistake. All right, what is the same mistake? Please tell. No, it's boards.len. Yeah, so we have boards.len there. Probably just len. Yeah, we have like some off by one error. Like, definitely. It feels like. Board.validate. If you for loop, you will start iterating serially. It's not off by one error. Oh, yeah, no. I see. For board and board. If board.validate. If board.is done. No, hold on. We need a getter and a setter. Hold on, what do we? Yes. Let's add a getter. Yes, you are all correct. We made a logic error, not off by one. Generate getter. Self is done. And then we say here, if board.is done, continue. Hey. All right, let's run this again. Run test. Ta-da, that was it. Sweet. There, we just had to make sure we didn't like loop over the same board twice. Oh, we can remove that. We can remove that. Okay, let's run this once more. Hey, 2980, submit. Amazing. 2 hours to find a bug. Oh no, I'm sorry. All right. We did it. We made it. Success. All right. I can take like another 10 minutes if people like want to take a look at I can take a look at people's answers. Just post them in chat. Hell yeah. All right. First one. Let's take a look. Without using rows or columns. Good question. You just did inline, didn't you? All right. So we read from standard in. That's nice. Score, boards. Oh, so you do have like boards and tempvec. Boards push temp, winner index. Whoa, what's going on? No, that one. Interesting. And then you have your board loop, break board. All right, so I very much like split it up into like multiple like different steps and like create a board struct and like did a object oriented. But this is like very like without like looking super deeply into every single part of the implementation. But this is more like, hey, we like create a matrix, it feels like, and just like loop over things directly. It's probably more efficient to not not do the way I like did these things, because we like sort of keep looping. We could like nest these things, right? Where's mine? Where do I have my little mark number? Like this could return like, hey, are we done or not? That'd probably be quicker. Using a 2D array is better because you would have two copies if you had rows and columns separately, right? Yeah, that makes sense. Although, you know, like the reindexing can be like expensive as well. So there's some stuff with that. Cool. Yeah, I like how this feels like if you're like going for a competitive, I want to like get an answer real quick. This feels like the better way to do it. But I went for not that. So our answers are different. Cool. Next one. Thanks for sharing, by the way. Bingo field. Enum. Not yet. Bingo. All right. So this feels very... Our answer is using a tuple of a bool, of our U8 and a bool. This one's using something way nicer, which is like, hey, we actually like remove the field using an enum. Oh, aliases. That's nice. We should have done that. That is way better. Yeah, exactly. Because we were like spelling out our types like rather intensely. Read board. Cool. Play board. 4-line in board. Yeah, nice. Is bingo. Cool. Kind of similar to us. Calculate the score. Cool. And then we have like the game loop. It's structurally kind of the same. All right. Cool. Thank you for sharing. Next one. UberX. Oh, we're doing Java. Didn't we like look at your answer like yesterday or the day before? Also like in Java? Because I feel like we looked at Bitbucket too and like also Java, so. Cool. All right, what do we got? Day 4, we have bingo, get bingo. So that's the, oh my God. I don't really know Java too well. Product of winning number and unmarked numbers. Ah, I see. Okay, so that's the final score calculator. That's the second final score calculator. Okay, struct class bingo, struct class board. Oh, static class. Sorry, not struct class. Cool. Yeah. So you also did like a board. And then mark, and then check winner, get some. Nice. Nice. Thanks for sharing. That's nice. Oh, and this must be, is this the main loop? Get bingo? I feel like it might be. I never know like what the entry point for Java programs is. But it feels like it should be here. Right? Get bingo seems like the entry point right there. Because this does like the main thing, the main IO loop and stuff. Oh, you were just running unit tests. I see. Yeah, that makes sense. Cool. Thanks for sharing. I rarely get to read Java, so it's a bit of a treat. All right, cool. Easy. And what do we got? We looked at this one. Yes. I want to make sure I get the right one. Museum solution is very cool. No type, semicolon, etc. Oh, wow. This is like the turbo functional variant. Wait, which day is this? Up, down, forward. That was Mondays? What are we looking at? Oh my God. Oh, it's just Wow. Let's take a look at the test file. Ah, I see. Okay, so just, yeah, you wrote the unit test here, and that's the input. Amazing. Cool. This is like, oh my God, way too intense. No. It's cool. It's very cool, but oh my God. It was just state machine gaming. This was, I believe, like Mondays or Tuesdays. I forget which day. First or second? I think second day was this puzzle. But yeah, all right, cool. Let me commit this. Day 4, commit to main. Push. All right. Thanks, everyone. And thanks for sitting through all the cat shenanigans. I gotta go run. My partner is arriving from Canada today, so I gotta make sure that everything's like nice and tidy. That was really fun having you, and I'll see you tomorrow again at what time? 9:30 a.m. UTC, 10:30 Eastern, or is it Northern Europe time? I forget what it's called. Doesn't matter. All right. Y'all have a good day. I'll catch you later.